NEC NFPA 70 Section 450.6 does not explicitly prohibit the proposed configuration of connecting the neutrals of individual motor starters to a central location. It states that the grounded conductor shall be connected to the transformer secondary neutral point or the enclosure of the transformer source. However, it's crucial to consider other relevant standards, specifically NFPA 79, the electrical standard for industrial machinery. NFPA 79 Section 6.4 1.1 requires that conductors shall be installed in a raceway. The proposed configuration, bringing individual neutrals and control wires to a central location, might not meet this requirement, depending on how it's implemented. It's important to ensure all conductors are properly protected within approved raceways or enclosures. Additionally, NFPA 79 Section 6.4 1.5 prohibits the use of equipment with exposed live parts or with an enclosure intentionally or accidentally grounded. This section raises a concern. The proposed configuration could create a situation where live parts are exposed if the enclosure of the central control panel is accidentally grounded. The practice of running multiple neutral conductors to a central point and tying them to the PLC control transformer grounded conductor could introduce unintended ground loops or increase the risk of a fault condition, creating a hazardous voltage potential in the enclosure. From a practical perspective and to ensure compliance with NFPA 79, it's generally not advisable to connect the neutrals of individual motor starters to a central location in the manner described. It's typically recommended to follow the more traditional practice of removing the transformers at the motor starters and supplying 120 volts alternating current from a new, dedicated transformer to the field enclosures. This approach provides better isolation, reduces the risk of ground faults, and simplifies troubleshooting. Furthermore, consider the implications for maintenance and troubleshooting. With individual transformers at each motor starter, a fault in one control circuit is less likely to affect the others. Centralizing the neutrals could make it more difficult to isolate and repair problems. When designing or evaluating industrial control systems, always prioritize safety and compliance with relevant standards. Thoroughly assess the potential risks associated with any proposed configuration and ensure that all wiring and equipment are installed in accordance with NEC NFPA 70 and NFPA 79. Remember these key points. Firstly, NEC NFPA 70 Section 450.6 provides general guidance on transformer grounding but does not specifically address the scenario of connecting multiple neutrals to a central point. Secondly, NFPA 79 Section 6.4 1.1 mandates the use of raceways for conductors, which may not be met by the proposed configuration. Thirdly, NFPA 79 Section 6.4 1.5 prohibits exposed live parts and accidental grounding, raising concerns about the safety of the central control panel enclosure. In summary, while NEC NFPA 70 Section 450.6 might not explicitly forbid the proposed configuration, NFPA 79 presents significant challenges and potential safety hazards. It's recommended to adhere to established industrial practices and prioritize safety by providing dedicated transformers for each motor starter control circuit. Consider the following factors when making your decision. 1. The specific requirements of the industrial machinery being controlled. 2. The potential risks associated with the proposed configuration. And 3. The need for compliance with all applicable codes and standards. Always consult with qualified electrical engineers and inspectors to ensure that the installation meets all safety requirements. Now let's consider some additional aspects to provide a more comprehensive understanding. Focusing on the transformers at each motor starter location can often simplify the design and installation process. This also helps maintain isolation between different control circuits, minimizing the potential for interference or faults to propagate throughout the system. This design choice also ensures that each motor starter has its own dedicated power source for its control circuitry. This is especially important for critical applications where reliability is paramount. If one transformer fails, it only affects the associated motor starter, while the rest of the system remains operational. Let's delve deeper into the raceway requirements outlined in NFPA 79. The purpose of using raceways is to provide physical protection for conductors, preventing them from being damaged by abrasion, impact, or exposure to harsh environments. Raceways also help contain any arc flash events that may occur, minimizing the risk of injury to personnel. Common types of raceways used in industrial environments include rigid metal conduit, electrical metallic tubing, and flexible metal conduits. When selecting a raceway type, consider the specific environmental conditions such as temperature, humidity, and the presence of corrosive substances. Proper installation of raceways is critical to ensure their effectiveness. All connections must be made securely, and the raceway must be properly supported to prevent sagging or damage. Consider the potential for accidental grounding of the central control panel enclosure. If the enclosure comes into contact with a grounded object, such as a metal beam or a water pipe, it could create a ground fault. This could lead to a dangerous voltage potential on the enclosure, posing a shock hazard to anyone who comes into contact with it. To mitigate this risk, it's essential to ensure that the enclosure is properly grounded and that all wiring is installed in accordance with NEC NFPA 70. This includes using appropriately sized grounding conductors and making sure that all connections are tight and secure. Regularly inspect the grounding system to ensure its continued effectiveness. Another important consideration is the potential for ground loops. Ground loops occur when there are multiple paths to ground, creating circulating currents that can interfere with sensitive electronic equipment. These currents can cause noise and distortion in control signals, leading to erratic behavior or even equipment failure. To prevent ground loops, it's essential to minimize the number of ground paths and to use proper grounding techniques. This may involve isolating certain equipment from ground or using shielded cables to reduce noise. The NEC NFPA 70 provides detailed guidance on grounding and bonding to minimize the risk of ground loops. Consider the impact of the proposed configuration on troubleshooting and maintenance. With individual transformers at each motor starter, it's easier to isolate and diagnose problems. If a control circuit malfunctions, you can quickly determine which transformer is supplying power to that circuit and focus your troubleshooting efforts accordingly. Centralizing the neutrals could make it more difficult to identify the source of a problem, as a fault in one control circuit could potentially affect multiple motor starters. If you decide to proceed with the proposed configuration, it's essential to conduct a thorough risk assessment to identify any potential hazards. This assessment should consider the specific characteristics of the industrial machinery being controlled, the environmental conditions, and the qualifications of the personnel who will be operating and maintaining the equipment. The risk assessment should be documented and used to develop appropriate safety procedures and training programs. Furthermore, consult with a qualified electrical engineer to review the design and ensure that it complies with all applicable codes and standards. The engineer can provide valuable insights and recommendations to improve the safety and reliability of the installation. It's also important to involve the local electrical inspector to ensure that the installation meets all regulatory requirements. The inspector can identify any potential code violations and provide guidance on how to correct them. They can also help ensure that the installation is safe and compliant. It is paramount to remember that electrical safety is not just about following codes and standards. It's also about using common sense and good judgment. If something doesn't seem right, don't hesitate to ask questions or seek clarification. It's always better to err on the side of caution when dealing with electricity. Always de-energize equipment before working on it. Verify that the power is off using a reliable testing device. Never assume that equipment is de-energized just because the switch is in the off position. Use appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. Follow all safety procedures and guidelines. Train personnel thoroughly on the proper operation and maintenance of the equipment. Provide regular refresher training to ensure that they stay up to date in the latest safety practices. Maintain detailed documentation of the electrical system, including wiring diagrams, equipment specifications, and maintenance records. This documentation will be invaluable for troubleshooting and maintenance purposes. Implement a regular inspection and maintenance program to identify and correct any potential problems before they lead to equipment failure or safety hazards. This program should include visual inspections, electrical testing, and cleaning of equipment. Address any identified deficiencies promptly and thoroughly. Do not delay repairs or ignore potential problems. In conclusion, when dealing with industrial control wiring, it's essential to prioritize safety and compliance with relevant codes and standards, specifically NEC NFPA 70 and NFPA 79. While NEC NFPA 70 Section 450.6 provides general guidance on transformer grounding, NFPA 79 presents specific requirements for conductor protection and grounding that must be carefully considered. It is always recommended to consult with qualified electrical engineers and inspectors to ensure that the installation is safe, reliable, and compliant. The best practices should be applied.